Hi, welcome back. My name is Stan and today I'm going to show you how to make your own super cool and robust lithium iron phosphate battery that can not only charge up your laptop, your phone or any devices that require USB power, but can also provide 12-volt output/input for when you need it. Super cool and dandy after all, but you might ask, why don't I go with lithium ion batteries, those NMC's 18650s that we were so used to? Well, the problem is, despite its energy density, which is much higher than lithium iron phosphate, which means a lighter weight, but also the safety is compromised. It may explode or fire if mistreated, physical abuse, which is not very safe after all, right? Well, definitely it's not that safe as compared to lithium iron phosphate, because safety is our #1 priority. With so many options available, like for example getting 10 pieces of batteries for only $40 million, is it better to DIY the battery or buy the battery? To answer this question, I will build the battery. We are going to see how much does it cost and whether it makes more sense to DIY or buy the battery. Let's get started. So we have our PD 100 watt fast charging board, and to change it to lithium iron phosphate you have to replace resistor 7 with the resistor that you need and resistor 8 with the capacity of your battery. Say your battery has a capacity of 12,000 milliampere hours. We will have to divide 12,000 by 0.8 to get the value of our resistor needed, and that would give us 15,000 ohms or 15 kilo ohms. So I've replaced the above mentioned SMD resistors with it looks super dodgy, but you can see it works. 3.6 kilo ohms, and this resistor is around 14-15 kilo ohms. I'm gonna cut a little bit of this insulation gasket to protect it from the SMD components, because this is all separately, they are not connected together, so that's a bit problematic. Solder it during the second time. The first time was hilarious, it didn't really solder well, but anyways, see, type C, USB, DC input jack. Put as much hot glue as possible to the part where you can put the hot glue on. So let's just put a generous amount of hot glue on the negative wire. Average dimension of 150 by 74 millimeters. We need to get something that's bigger than this, but also not too big. I want to get a transparent one. So maybe we're looking at something like this. Right, so this is the ammeter that shows how much current is going in and out of the battery. Some 12 gauge wires, switch, and the fuse. The nickel spot welding strip for the batteries. A battery management board. A charger. The PD power bank, binding post for the output/input. So these are all the equipments that you really need. We are going to choose a very good location. Could be here, it could be here as well, but I'm thinking here will do the trick. So I'm just going to use a Sharpie to mark out the 2 circles that we need to drill. Then we can basically put our binding posts in there. Right, so now we need to spot weld the lithium iron phosphate battery. So this is a brand by Little Kaler, 10 pieces, with 2 left here, even though they rated at 6,500, but I got only 6,000, 5,900, 6,243, so it's not really 6,500. How to spot weld these batteries to make a 12-volt battery pack? It's actually quite simple, so sit back and relax and enjoy the video. You need a spot welding machine here. This spot welding machine is by Finercy, type number SWN10. I've tested it on a 0.15mm sneaker strip, and it is fantastic. What you need to do is to basically get your battery, which is right here, and also the top piece, You can find the 3D model on Thingiverse, alternate the polarity of each pair of the battery. So basically, if this one is negative, we have to put the positive facing up. I'm gonna put it like this. Push the batteries in. Very simple, right? It's just looking at the battery. Now we have to put this top piece on. Just have to give it a little push. We need to cut several nickel strips to the size. Oh, that is pretty. Have nickel strips, be careful about the edges, they are quite sharp. And now we're gonna cut many pieces of it to equal lengths. Just cut it like this. And we're gonna repeat this for the same. All you need to do is to turn on your spot welder and basically put the 2 nickel strips suspended like this. Thereafter, you can spot weld it by placing one of the leads diagonally. Make sure to touch the batteries and push on it. The current will be detected. The spot welder detects it and pumps out a small current. There we go. Perfect. Pump out a current. Now we're gonna do it for the other side as well. And also I forgot to mention that the battery must have the same voltage before the spot welding, because if you weld the batteries with different voltage, they may pump a lot of current. So yeah, do remember that. So that's it, something like this. Now how to connect series connection. So say you have 4 batteries. How do you make a 12-volt battery? Well, the answer is simple. By connecting them in series connection in a straight accordion line. So this way, you would get 12.8 volts at the output with positive here and the negative here. This is the 3.2 volt, 6.4 volt, 9.6 volts potential. So this way you get 12.8 volts. For example, if we want to put this pair of batteries in series, we just have to something like this. And when you measure it, yeah, we get 6.7 volts. So we definitely cannot weld here. Instead, we have to weld here. If we measure it from the top to bottom, we will get 9 volts to 10 volts. Yep, we get 10 volts. Very nice. And because we get 10 volts from here, we can finally weld this too. Welding. There we go. That's it. 1, 2, 3. And if we measure the voltage from here and here, we will get a combined voltage of 13.4 volts. So that's the voltage of our 4S2P lithium iron phosphate battery. We need to take out our BMS board and can see we have only B- and P-. So this B- we are going to connect to the negative of the battery. That's pretty self-explanatory. But before that, you can see that I don't want the BMS connection to be exposed to the batteries. So what we need is a special tape called the insulation gasket, which looks something like this. It looks like some green kind of paper-like, kind of glossy-like thing. This is to prevent the wires from short-circuiting the battery, because this actually is a negative terminal. So if we short-circuit, it may, yeah. Right, so what we have to do is to just cut a appropriate length. This way, our batteries will be pretty well insulated. Now you can finally safely put the BMS like this. But if you want to shortcut, what you can do is to actually spot weld nickel strips on here, on the BMS. Then you can just directly connect it to the negative terminal. There we go. So it looks something like this. Spot weld to the negative of the battery. So something like this. So this is your B-. And just basically double-side it to the BMS terminal. So you just put double-sided tape on the BMS. Tightly fitted onto the battery pack. Something like this. There we go. That's how you connect the negative of the BMS. I strip the positive wire. This is connected to the plus 12 volts potential of the lithium iron phosphate battery, so we do have to solder it. The problem is not about the complicated, it's about this type of batteries are very sensitive to high temperatures. It's also not just lithium ion batteries, but this type as well. This yellow wire is basically connected to the negative of the 12 volt potential. So in this case, it's the bottom here. Go. So this is the yellow wire, which is the second wire of the BMS. Third wire is basically connected to the positive of the battery right here. So the black wire is connected to the negative here, which is in line with the B minus. So basically our battery pack is completed with all the wires something like this. To the P minus and the B plus, I get 13.45 volts. So it seems that the BMS is working fine. Need to solder a thick wire P minus. So let's do it now. You might want to, kind of wear the gloves, because it can get extremely hot, because we are going to heat up the solder on the 12 gauge wire. 12 gauge wires are very difficult to solder, that is definitely understandable, but with a little bit of patience, everything is possible. And now you can see it successfully works, and we can put the batteries in like this, and yeah. So this ammeter would measure the amount of current going in and out, regardless of whether it's going in the battery. If it's going in, it's positive. If it's going out, it's negative. There you go. That's our circuit. So here's a simple illustration of the switch that I took apart from the hairdryer. So this is off position, as you can see. Mode 1, Mode 2, Mode 3. So this is Mode 1. It only connects this terminal right here. So basically this is turned off, doesn't connect to here. Mode 2, both of these are connected. Mode 3, negative is also connected. So basically what we're gonna do is to connect the positive to this green wire right here, which in this case I'm just going to replace it with a brown wire because it's thinner than my previous thick wire. Once that's done, you can just basically heat this thing up, seal it up. Then we connect this to the positive terminal. Heat shrink, saves everything. And now what we have to do is to connect the negative to our negative terminal. Solder it to the negative of this switch. So it seems like when I turn on to position 3, nothing works. It only works when the BMS receives power from the input. So they know, oh, it's legit a battery that's connected to it and not a, kind of like a power source. It knows, it's quite an intelligent circuit. So we strip both of these black and red wire and we drill a hole in the binding post. Binding post fits. The washer, big washer, small washer, 2 nuts. I have decided that I can use crimp. You can see it fits nicely onto this terminal. Because this apparently doesn't like to get soldered. Because I think it's some kind of metal, probably aluminium or something like that. For the overcurrent protection. These are the balancing wires for the BMS for the USB charger. Apparently it needs a BMS for it to work, or else it will just shut down, because it doesn't like that we are putting so much voltage on it, yet we don't receive any signal from the BMS. So now we're just going to solder wires to the BMS terminals. Now we will have to clean up our entire workbench. So everything has been cleaned up nicely, and we have left this battery and this clamp right here, which I glued to this switch. You can see, pretty nice, I have to say. It's quite solid. So we measure the voltage here, and we will probably get around 12 volts. Here we get 13 volts. Doesn't do anything. Oh, I flipped the connection. What? Bruh. Switch the knob to the position. Draw some current. Oh yeah, 3 amps. Look at that. That is very high current. Oh yeah, fast charging. Look at this. 2 amps. So now it's time to do the capacity testing. So our lithium iron phosphate is fully charged, and the voltage across the 2 connector pins is around 14.35 volts. Awesome. But before we connect the battery analyzer, we have to check the equilibrium voltage of the battery and see whether they are balanced or not. So I'll be checking it through this several resistor connection right here. It's 3585 or 3589. Third battery is 3592, and the fourth battery is 3578. So they are pretty much balanced, and thus the combined voltage would give you approximately 14.35 volts. Now we're gonna set the battery analyzer to discharge at 2.4 ampere. This is basically 0.5 C of the capacity, 2.4 amps. Clear parameters. Right, and now we can just basically connect the jack, the positive to the jack, something like this. See, we have 14.3, so let's get started. On. So the battery voltage drops quickly, and we'll see you once the battery capacity is completed. Right, so it's now morning, and the battery capacity has been finally ended the test, and the capacity came out to be 154.320 watt hours, capacity of 12 amp hours. This battery capacity is officially 12 amp hour, 150 watt hour, and this one is a 12.8 volt lithium iron phosphate, 97 watt hours per kilogram. This is with every single electronics being installed on the battery. So you can see this battery is actually quite energy dense. So we're gonna measure each of the cells individual voltage and see whether they are still pretty good. 2.6, pretty good, okay. 2.9, 3 volts. 2.9, okay, still not far off. Normally it will get better with every cycle you charge and discharge. We're gonna test the fast charging of this battery with a 65 watt GAN charger. We're gonna turn the switch position to position 1, position 2, position 3. Position 3 would be the USB. Very good. I'll put it into the type C. Take a while. Right. Whoa. 4 amps. We are pretty close to 6 amps. Looks pretty good. See right here is around 5 amps, 5.4 amps. So yeah. Say you're trying to edit a video on the go and your laptop has 20% battery remaining. No worries, just plug it in and you can edit on the go. And there you have it. Here is our DIY 150 watt hours lithium iron phosphate battery. And now we're gonna compare whether is it cheaper to DIY the battery or buy the battery. So with every single components in my batteries incurred, for example, we have the batteries, the BMS, the ammeter, the USB, the box, and even all the miscellaneous components like the parts, the binding posts, switches and everything, that will only cost us around 90 Singapore dollars, which is approximately 1.66 watt hours per Singapore dollars. Guess how much the buy version costs? $172 for the same battery capacity from a reliable Amazon seller. That is almost twice. No wonder the energy cost per dollar is 0.89 watt hours, which is kind of low as compared to the DIY version. So we can safely say that DIY is the real winner of this competition. And not only that, even if you incur the spot welder in the cost, it still not even comes close to that of the buy cost, which is like $172. Granted, the spot welder may be cheaper. It only costs 60 Singapore dollars for a good quality Vinci spot welder, so that's actually very nice. And not only that, when you DIY more batteries down the road, your cost of production will be even cheaper because normally you buy the nickel strips in quite a lot of quantities. And there you have it. That's about it for my lithium iron phosphate video. Thanks for watching, have a great day and see you in the next one.